Welcome to all the curious learners. I am Dr. V. Persis, working as Associate Professor in the Department of Computer Science and Engineering, Adikavinana University, Rajamahendravaram. Now I am going to present the topic Perceptron, the building block of artificial neural networks. These are the contents I am going to cover: linearly separable versus non-linearly separable data, few examples and its working, perceptron learning algorithm, an example problem with perceptron, solving AND gate and drawbacks, why do we need MLP, multi-layer perceptron, followed by self-assessment and an assignment, and finally I'll show you visual demonstrate perceptron and its working. This perceptron topic in the course of in the program of BSc Artificial Intelligence is covered in the subjects of machine learning, deep learning and neural networks. Before going into the perceptron topic, we should know what is linearly separable data and what is linearly inseparable data or non-linearly separable data. Here there are two graphs. It is self-explanatory. Graph A, we can see that the two sets of points, let me show you, they are here we see two sets of points, green dots and blue dots. These two sets of points or classes we are able to divide with a straight line. Then in that case, this is called linearly separable data. Whereas coming to figure B, here we see blue dots and again green dots, but they cannot be separated with a straight line. So this is called non-linearly separable data. Now we shall see three examples, the familiar gates AND, OR and XOR. So if you see AND gate, let me explain only this AND gate. The other two you can check it on your own. AND gate, let me say there are 4 points, two inputs x and y axis. Let me say 0 0 0 1 1 0 1 1. We know for 0 0 the output is 0, 0 1 output is 0, 1 0 0, 1 1 is 1. This is AND gate output. So here you take this point as all these three red dots, circles belong to the class 0, because this is 0 0. Let me say this is 1 0, this is 0 1 and this is 1 1. So this is these three belong to one class, this is another class. You can separate them with a straight line, or you can check it. And XOR also, it's an exercise for you. See here, by seeing this XOR, you can see that we cannot separate this with a straight line here, because a straight line cannot, these two belong to one class, these two belong to another class, so a straight line cannot separate them. This is an example of non-linearly separable data, and or are examples of linearly separable data. So perceptron is the simplest type of artificial neural network, and it helps in the classification of linearly separable data. How it works, there are, by seeing this diagram, we can understand there are inputs. Here there are 4 inputs. Actually it should be x2, this is x3, x4. Okay, but in the AND gate we have only 2 inputs, so 2 are sufficient, and the corresponding weights. Here we see sigma, summation and bias. Use multiply, we call them as weighted sums, because every input is multiplied with its corresponding weight plus bias term is added, and the output, whatever output you get, for that step activation function is applied. If it is greater, step activation function, whatever output you get from this point, if it is greater than or equal to 0, the output is 1. If it is less than 0, the output is 0. This is as simple as this, the perceptron and its working. So we say as one input layer where all the inputs, and an output layer, and the output will be either 0 or 1 based on the step activation function. So this is the perceptron learning algorithm. We need to initialize weights, bias and learning rate to some random values. Learning rate also will be there. We need to go in the forward direction, add bias to the weighted sum of inputs. This is the bias. These are the weighted 2 inputs I have taken, x1, x2, weighted sum w1 x1 plus w2 x2. Then apply step activation function. So I have shown you this in the previous picture. And then now we have to identify the error, calculate the error. If target output is same as obtained output, then there will be no error. If there is difference, there will be error. If there is error, then we have to proceed to step 4. We need to update weights and bias. This is also very simple. So weights we have already taken here. See W1, W2. We will get new W1 and here it is new W2 is equal to existing old W1 plus learning rate. We have already initialized it in the first step. Error is calculated in the step 3 and X1 is the input, and W2 again it is updated in the same way. Bias is also updated as B is equal to B plus learning rate into error. Now this procedure has to be repeated until all training examples. Here in the case of AND gate or OR gate, we have 4 cases, 0, 0. These are the training examples we call them. So these are the 4 training examples. Your perceptron should give the correct output. Until this point, we are going to repeat the epochs. So this is the simple example I have solved, taking W1, W2 as initial values like this and bias as initial value. You can take any other values also. And epoch 1, after epoch 1, see here X1, X2, the inputs, and W1 I have taken the initial values 0.3, 0.5 bias, and this is the output by applying the step activation function you get y predicted and actual y. See, actual y should be 0, 0, 0, 1. We know the output of AND gate, but here see, here we didn't get this one. There is an error here. This is also error because so error is showing here. And now so we go to the second epoch, weights and biases are updated, we get new values. So this is how again in the second epoch also there is an error here. Now finally, now we go to the third epoch, weights and biases are updated. See, finally we get all zeros, there is no error. So the algorithm terminates, we can say. So this is how perceptron works. Drawbacks with perceptron, it cannot see this kind of complex patterns because here it is not a straight line where the two sets of points are divided. So this kind of complex patterns cannot be modeled with perceptron. For this we need non-linear activation functions which are used in artificial neural network. This is how an artificial neural network looks like. This is also a basic multi-layer perceptron, we say, not a single perceptron, but we need in multiple layers. Input layer we have, and in between there will be many hidden layers, and output layer is also there. So with this, hope you understood the working of perceptron and how it is used to classify the linearly separable data. Now based on this, three simple questions. What is the output of a perceptron with the step activation function? What did we get with the step activation function? Continuous values? No. Probabilities? No. Only 0 or 1. We got either 0 or 1 as output of the step activation function. So this is the right answer. Which of the following is used to update weights? So to update weights, it is not activation function, it is not loss function, it is learning rule. Perceptron solves what kind of problems? It solves classification problems. So very simple questions. This is one of the questions given in the GATE exam 2 years back. So by seeing the question, it seems to be difficult, but no, actually it is very simple question. See, the question is, which of the following is true? One is linearly separable or not. So figure 1 is two sets of dots linearly separable. Figure 2 is linearly separable. No, with a straight line we cannot separate them. Figure 3 is linearly separable. No, because these not with a straight line we are not able to separate them. Figure 4 is linearly separable. Yes, two answers. This is MSQ, multiple select type of question. So this is the assignment that can be explored, that has to be completed. You can train a perceptron to implement the OR gate using the perceptron learning algorithm. Take the initial values as follows. Learning rate is equal to 0.1, initial weights 0.2 minus 0.1, initial bias 0.0. You need to mention how many epochs are needed to get the correct result and show the intermediate calculations also. Hope this is well understood. Thank you. Now I'll show you one simple working of this perceptron. So let me show. See, this is the playground.tensor See here, you can very clearly see one data set. 4 different data sets are given. I'll take this one. This is this linearly separable? No. So let me show you. Suppose let me say activation function. I'm taking the simple linear activation function like step activation function. So now see, there are hidden layers. We can add more hidden layers. We can reduce them. At a hidden layer, I can add more neurons or reduce them. So many things I can do. You can play with this. So now when I execute this number of epochs, so what happens? See here, I am trying to run this. Here you see test loss and training loss. even with many number of epochs, the loss will be 0.45 like that. That means 50% of the samples are not, we cannot classify them properly. Understood? So now let me take the linearly separable data. This is linearly separable. You can separate them with a straight line. Now I take again the same, what do we say, learning rate, linear function. Let me check the loss here. Loss should be low or high? Loss should be low. That means all the samples are, we are able to classify them properly. Let me see the epochs. See how very quickly the loss has come to 0 because it is linearly separable data, right? Now let me take, suppose activation function as sigmoid. I didn't teach you sigmoid, but it is nonlinear activation function. Let me take this data set and let me run this. Because it is nonlinear activation function, we can say, see here, earlier the loss was very high, but now the loss is reduced because it is only one hidden layer. If I take more than two hidden layers, more than one hidden layer, the loss will be even reduced to even smaller number. Okay, so this is how perceptron works. A single perceptron, multi-layer perceptron, and artificial neural networks. Hope every one of you have understood this clearly. Thank you.